Okay, this is our lesson on reasonable domain and range with continuous scenarios. Okay, so we're going to make sure we understand the difference between domain and range. Reviewing, the domain is our x values, the range are the y values. Okay, just a reminder that a function is either discrete or continuous. Hopefully we watched the previous information about discrete, and now we're going to focus on continuous. So again, discrete allows the x values to be certain points and is usually only integers and whole numbers. Continuous function, that's what we're going to focus on today, allows x values to be any points and can include fractions, decimals, and irrational values. So our continuous would be this here. This would be considered our discrete. Okay, so our continuous is a line. Discrete is something we count. Okay, so we're going to focus on continuous today. So just a little bit of a reminder about graphing inequalities, because that's what is important, because remember, we need all numbers that include decimals and fractions and irrational numbers. So we use inequalities to represent all of those in between numbers. So we want to make sure we remember a couple things. A closed dot means that it includes that number. So x is less than or equal to 11. That means all the numbers that are smaller than 11. So we have it include the number 11 and then every single number to infinity that are smaller. So we use an arrow to include all the numbers to the left. So it's all of our decimals in between. This one is open dot, which means that it does not include that. So x is greater than 11. So we don't include 11 because 11 is not greater than 11. So we use an open dot to say that we want to stop at 11, but we're not going to include it. So everything to the like decimal point, 11.000000122222334455567, right? It doesn't even matter. It's just every number that is bigger than 11, not including 11. So that's why we put it as open circle, don't include it, but every number to the right, including fractions and decimals. So we want to make sure again that we understand that this would be all of our x values are the line. So we want to include this 4. So the x's include 4. They are also bigger than 4. So we want to say they're greater than 4. And that's how we would represent the x values. So what are some x values that we can represent? Well, x can be 4, x can be 5, x could be 6.7, x could be 7.3 repeating, right? It can go all the way to infinity to the right. Okay, what if we had something like this? Well, x, remember, it's not equal to because we don't want to include 3, but we want to say all of the numbers that are bigger than 3. So what kind of numbers can x be? Well, x cannot be 3, but it could be 3.1, it could be 4, it could be 6.9 repeating, it can be any number, but not including 3. Okay, well, what happens if we have restrictions? So we don't say all the way to infinity. What if we say, well, we have a lowest number we want 1 and a highest number we want 5. So all of these x's are in between 1 and 5. Well, we want our numbers to be bigger than 1, right? So x has to be greater than 1, not equal to because it's open, but we want it to stop. We don't want it to be bigger than 5, right? We want 5 to be the highest number. So we want x to be less than 5. But we wanted to include 5 because if you notice, we used a closed dot. That's how we would write this scenario. Okay, let's try one more. So we want to look at the lowest number, which is -2. The highest number is 4. So all the x's have to be in between -2 and 4. So we want to include the -2. So x's are bigger than -2. They're also equal to because we have a closed dot. But we want them to all be smaller than 4, right? So all of the numbers that are smaller than 4. So that means we want x to be smaller. So 4 has to be the biggest, but we're open and we're not going to be including 4. So we're not going to use it equal to. Okay. How does that take into account if we're on a graph? Well, the same scenario, right? You still have your x-axis here, right? So this is my x-axis. So what is the lowest? Well, the lowest x value is what number? -8. And what is the highest x value? Well, our highest value is +8. All of the x's are in between from this line. They're all in between -8 and +8. Okay, so let's see. All of the x's are bigger, right? Because they're going to the right, so they're larger. All the x's are larger, and it was a closed dot, so it's equal to. But they're not bigger than positive 8. They're actually smaller than positive 8. So 8's the bigger number. And again, it's equal to because that was a closed dot. This is how you write a continuous domain for a graph line. Okay, let's look at if we were talking about range. Okay, so again, we want to look at the lowest y value. So here's our y-axis. Well, what's the lowest? Well, on your line, the lowest of the points is at what number? -2. What's the highest y value? Well, here's our highest point of the line. So what number is that at? +2. So we're not using x, we're talking about the y values because we're talking about range. So the y's are between -2 and +2. Well, all the x's or the y's are all bigger than -2, right? So y's are bigger. It's equal to because of the solid line or a point. And we have 2 as the highest, so all the numbers are actually smaller than 2. So 2 is the biggest number. And we're equal to because, again, if it's a line or a point, it's considered equal to. Okay, so that's what we're going to be working with today on a graph. So here's an example. Domain would be the lowest domain, or x is positive -2, and the highest is 4. So the highest is 4. This is open dot, so if you notice, I don't have an equal to on that. Then we have our range, which is the y value. So the lowest y value is -3, and the highest is +2. So it's equal to because we have a solid dot, and it's not equal to because we had an open dot. Okay, so go ahead and pause it, see if you can get this one on your own. So my domain is 1, 2, 3, 4, 5, 6, 7. So -7 is the smallest. And +1, 2, 3, 4, 5 is the biggest. Domain is my x value, so in between x, all of the x's are bigger than -7 or equal to, but they're smaller than +5. Not equal to because it's an open dot. So let's do our range. So what's the lowest range? So 1, 2, 3, -3 is the lowest. And then we have +1 is the highest. And we're talking about range this time. X's are all above. So they're greater than or equal to. But they're small. The highest is at +1. It's open. So it's not going to be bigger than 1. It's not going to be equal to 1 either. Okay. So you can pause and try it on your own. Okay, so our domain, the lowest domain or x value is 0. The highest is 4. Domain is our x, so we're between 0 and 4. All of our points, meaning all the points on the line, are all bigger than 0 or equal to. And I think they're equal to, yeah. And then they're also equal to 4 or smaller than 4. And then our range is the y value, so the lowest is -4, and the highest is +4. And again, we're talking about range, so it's the y values. All of the y's are bigger than 4, -4, they're equal to, and they're all smaller than +4 or equal to because it's a solid dot. Okay, try the next one. So my x is -4 to +4. All of the x's are greater than or equal to. Oh, not equal to, excuse me. And then they stop at 4 but don't include it. Okay, so no equal to on these. And then our range, the lowest is 1. The highest is 1. So those are the highest and lowest. So -1 and 1. Range is y. Open dots, so y's are all bigger than -1 but smaller than +1. Okay, try the next one. Domain, highest and lowest. So the lowest is -4. Remember, you always go least to greatest. 2 is the highest, so all of the x's are in between there. So they are all bigger than -4 or equal to, but they're not equal to +2. They're all smaller than 2. And then the range, The lowest is 0, and the highest is 3. And we're talking about the range, so all of the y values are bigger than 0 or not equal to, because remember that was an open dot, but it was a closed dot up here, so they are equal to 3 or smaller than 3. Okay, and then let's do another one. Domain is -1 to +2. So -1 to positive, excuse me, what was the domain? And then we want all of our x values are bigger than -1, not equal to, and then 2, they're smaller or equal to 2. And then our range, the smallest, is not actually, it's not 2, even though the dot is at 2, because if you notice, our line actually went all the way down here. What number is that at? That number's at -3. So the range is -3 is actually the smallest, and 1 is the highest. And so even though there's not a dot there, it's a point, and a point is considered equal to. And then the highest was 1, but it's not equal to 1. Okay. Here's another example where there's points, but the line might not necessarily be the exact minimum or maximum. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9 is the smallest. And 1, 2, 3, 4 is the largest. Okay, so we have, these are boundaries. So they're equal to, because they're solid dots. And then let's talk about range. So the lowest range is here. The highest range is here. So we got -1, 2, 3, 4, 5, 6, 7, 8, 9. And then the highest is 1, 2, 3. There's solid dot and solid dot. So we are greater than -9, but less than +3. Okay, so here's no dots, but again, your domain is the highest x and the lowest x, right? So the lowest x is -1, 2, 3, 4, 1, 2, 3, 4, 5, -5. And the highest is 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like 9 to me. So all the x's are greater than -5, but less than or equal to -9, because it's a point, even though it's not a solid dot that you actually see. Unless it's open, that's obviously has to be indicated. The lowest and the highest y or the range. So -1, 2, 3, 4, 5, 6, and +1, 2, 3, 4, 5, 6, 7, 8. It's very important we go least to greatest. So these are our y's. So all of the y's are bigger than or equal to, but not larger than, but less than or equal to 8. Okay, here's an example where what if we don't have stopping points, right? So the blue line represents the line we're referring to. So our domain, if you notice, there's no smallest number because this is going to actually go on forever to every negative number. And the positives actually don't have a positive because they're going to go on forever. So our domain is all real numbers because there's no least or greatest. And then our range, well, we don't have a smallest because again, it's going down. So it's going to hit to infinity negative. Let's look if we have a highest point. Well, this is the highest point of the line. So we have all of the y values that are less than or equal to 2 because that's the highest number. We just don't have a lowest number. Okay. Here's another example. So the domain, there's no stopping at negative and there's no stopping at positive because we have arrows on the domain going to infinity. Our range is the y values. Well, we don't have a highest y, but we do have a lowest y. So this is the lowest. So all of the y's are greater than -5. No highest. So let's try this one. Okay, so it says identify the domain. So remember my x's are going to infinity. So it's going to continue both ways, positive and negative. So we have all real numbers. Okay, our range is Well, we don't have a maximum, right? Because it goes on forever, but we do have a minimum. So we do have a lowest point, which is -6. So all of the y's are what? They're bigger than -6. So all the y's are greater than or equal to -6. Okay, let's try another one. X. So we have, if you notice, we have a lowest x value, which is 0, but we don't have a highest x value because we go to infinity because of the arrow. So all of the x values are greater than or equal to 0. And then let's go to y values. Our y values, well, we do have a lowest, which is 0, but it goes to infinity because of this line. So it's going to continue on forever. So it's going to hit every positive number. So all the y's are going to be greater than or equal to 0. Okay. Application answers will depend on whether it is discrete, which is countable, or continuous, which is measurable. Remember, negative and decimals may not exist in real world situations. Discrete would be numbers that you can count. Continuous are numbers in between fractions, decimals. Okay, a discrete domain will have a discrete range. Continuous would have a continuous. Okay, so discrete applications like how many hours were worked, how many tickets were purchased, how many people attended. So in your real world scenario, can you count the answers? Continuous would be something that you measure, like how much sand. So if you're weighing something, how many miles if you're measuring with distance, how tall if you're measuring with a ruler or something like that. That would be continuous. So you would have different types of answers. So you would be able to list your numbers, right? On a continuous application, you would have 0 to 3. So all of your x values might look something like this. So that's continuous versus discrete. Jeremiah's car gets 20 miles per gallon. If the amount of gas used is a function of the number of miles driven, what is the range? If the domain is x is less than or equal to x, which is less than or equal to 6. Well, if I know my lowest x value is 3 and I get 20 miles to gallon, well, 20 times 3 is going to be what? 60. And then what do I do? 20 times 6, I get 120. So all of my y's or my outputs are going to be 60, between 60 and 120. Because I'm using these x's, these have to be my y values or my outputs because they're my inputs. And that's it. Oh. We'll go ahead and you can try this one, just listing the domain. Let's see, what's the maximum? So we can have a maximum. So how many 2000s will fit in? Basically, it's asking if you have 160,000 max, how many of those 2000s would fit into that thing? And there'd be 80. So I can count, right? So I have I can have partials. So I'm weighing something with a measuring. So it's going to be between 0 and 80. So I would say all of my x values can be equal to 0 or they could be equal to 80. So my numbers will be between 0 and 80. That's it.